see if this helps by zooming in. So number 14, again, it says it's similar. We need to follow the steps of similarity. FED, FED. Okay? And then QRS, QRS. So it's telling us the direction. So QR is to FE. Okay? So FE and QR. So you're going to go, it doesn't matter which one you put first. 2x minus 7 is equal to 35, right? And then you notice how there's not anything over here? But there is something over here. So we're going to, if we started with this guy, underneath it will be 11. If we ended with this guy, then underneath it will be 77. Okay? It's kind of like saying fraction, fraction, and set them equal to each other. Okay? All right. Now it only works if you follow the directions. They have to go in the same direction. So this has to relate to this, and this side has to relate to that side. As long as they do relate to each other, it works every time. Okay? And that's proportionality. So I can say that because the definition of similar triangles. Right? And now, what's my first step?
Multiplication.
Yeah. I'm just going to multiply. Multiply. So I got 77 times 2x minus 7 equals 35 times 11. Now, this is a little bit more complicated. So in this case, I'm going to actually multiply those numbers out. Does that make sense? It'll get too weird if I don't, because we're doing subtraction. Okay? So, I'm going to have to do 11 times 35. Does anyone remember the trick of 11? Okay, there's a trick to 11. You take these two outside numbers and you add them up, and it becomes the middle number. Okay? So it's 385. That's a trick for 11. Okay? And two-digit numbers. Okay? Now, you could just say 10 times 35 is 350, plus 35 is 350, plus 35 is 385. Does that make sense? Okay? Alright, and then we got everybody on the block gets the paper. That's called distribution. So it's not just simplifying anymore. We are distributing, and so you can't call distribution simplification. They won't let you on the state test. Anytime you see this, they're going to want distribution. Okay? Alright, so 77 times 2, that would be 14 carried to 1. 14, that would be 15. And then x minus, and then 7 times 7 is 49. And then 7 times 7 is 49, plus 4 is 53. Right? So 539. So that's a big number, but oh well. It's just numbers. Okay? So let's rewrite that so it looks prettier. 539. Okay. So now we did distribution. What do we want to do?
Addition property of equality.
Addition property of equality. Good. 539 plus 539.
Why didn't you do it the other way?
Why would I want to move it that way?
Never mind, I thought the other one was bigger.
Oh, but what's the key to the problem? Getting x alone, right? So we always want to move pieces away from x. So always do the opposite of what's happening to x. Remember, SAD MET. Subtraction, addition first. So we always start with subtraction, addition, always the opposite, OPP. How can I explain it? Right? And then, what we call that, that's algebra. But what do we call it in geometry? Addition, property of equality. Okay? And so when we do that, we get 154x equals, big number. So 9 and 5 is 4, carry the 1. 3 and 9 is 12, carry the 1. And 5, 8, and 9. Okay? All right. So, step 5. What are we going to do for step 5?
Divide.
Good. So, division, property of equality. Right? All right. So, these cancel, of course. That's easy. That's x. All right? But, what do we do with that guy? So we break them down. Just use that upside down division. I mean, you can throw them in your calculator if they let you have one. But if you can't use a calculator, remember the computer, it's on a computer. We're going to be doing this test next week. Just for fun. Okay? And it's going to be on a computer. And you have to use, if they let you use a calculator, it'll be up in the left-hand corner. If they don't let you use a calculator, that's what you'll be doing this for. That's why I'm teaching you this. Okay? So if you look at me and go, but I could do that in my calculator. Sure. Unless they don't give you one. Okay? So know how to do it. Alright, so I'm just going to break it down. Now I don't know if 4 goes into both of those. And I don't have a trick for 4. So I'll just do 2. It's not a big deal. Right? I do have a trick for 3 though. Right? What's the trick for 3? If they add up to be a number divisible by 3, then it's divisible by 3. But 6 and 4 is 10, and it's not divisible by 3. Okay? So, I'm going to start with 2. 2 goes into 9. What?
4 times.
4. Carry the 1. 2 goes into 12. Notice how I'm making this a new number. 2 goes into 9 4 times. 8 from 9 leaves 1. 2 goes into 12 6 times. 2 goes into 4 twice. 2 goes into 15 7 times with 1 left over. And so now you have the 14. 2 goes into 14 7 times. And now you're thinking, okay, it's either 7 or 11. What's the trick to 11? Do you remember? The outside numbers add up to be the middle. What's the outside numbers? 4 and 2. They add up to be 6, right? So this is divisible by 11. 11 goes in there 42 times. Now you might want to do long division for that. 46. Well, I use short division. 46, that's 44, right? So I know that that's 4 times. 44, that's 2. And then 22, 11 goes into 22 2 times, right? So there's another way you can do it. Or you know the trick, the 4 and the 2 come down because they add to be 6. And then we know the trick to single digits is they're the same number, right? So 77 divided by 11 is just 7. Now, what goes into 42 and 7? 7, yeah. How many times? 6. So that means x is 6. And that's simplification. Okay? So we know this x is 6. Now if we wanted to figure that out, again, we would plug it in. We would say 2 times 6 minus 7, which is 12, minus 7, which is 5. So we know that that side is 5. Okay? And that would be substitution. Right? And simplification. Okay? If they wanted you to solve for the side. If they just